Okay, today we're going to talk about multiplying polynomials. In class, I discussed what a polynomial is, and so today we're just going to go through some of the examples. Before I forget, you may want to try to work the examples. Pause before I start working them. Do what you think you can do on them, and then watch me work it out, pausing when something is different than what you have. That's a great way to allow the notes to help you understand what's going on. All right. So what we're going to discuss today is multiplying polynomials. And one of the things that's important to know is that we just talked about the exponent laws and stuff. And so they're going to come up. Mainly the one that says whenever you multiply and you have the same base, you add their exponents. That's going to really be the issue because we're multiplying. That means we're going to be adding exponents. Keep that in mind. Remember the distributive property. Talked about that in class as well. Remember what multiplication looks like, where you got parentheses right next to one another, understanding what a term is and things of that nature. Just kind of take a little inventory of what you have before you just jump into the problem. Now, I got a hint here. It says when multiplying, that's not spelled right, but when multiplying polynomials, multiply the numbers to numbers. That means coefficients to coefficients, and matching variables together. So all the x's together, all the y's together, all the z's together whenever you multiply a particular term times itself. Alright, so how do we actually do that? Alright, so we have this little demonstration here, or not demonstration, but a step 1, 2, and 3. Step 1 says, if a polynomial is written to an exponent, expand it out. So if you ever get a problem like this, this means x minus 6 times x minus 6 times x minus 6. Notice I got 3 of those x minus 6's right there. Then you'll multiply the first 2, and whatever you get there, you'll multiply that times the last one. This doesn't mean x to the third and 6 to the third. It doesn't mean that because you have a minus sign in between. If this was x or 6x to the third without the minus sign, then yes, you would do that. So understanding that there's a difference between what you see up there. In fact, let me show you this example real quick. I was just talking about 6x to the third and x minus 6 to the third. Okay? This actually means 6x times 6x times 6x. This actually means x minus 6 times x minus 6 times x minus 6. But we have different properties that can help us here. I have 3 x's, so that's x cubed. 6 times 6 times 6, I don't know what that is. 6 times 6 is 36. And whatever 36 times 6 is, because I'm trying to hurry up, I don't know. But anyway, we'll just say 6 cubed for right now. This means the same thing, except you cannot multiply like I did here. This means this x times this, and this. Everything gets multiplied by the x. So does this 6 get multiplied by everything. So does this x get multiplied by everything. It's a different thing whenever you have a plus or a minus separating your numbers. So please be aware of that. If you have numbers or terms or variables and they have a plus or minus separating them, try to separate from what we were just doing, just only working with exponent properties. All right, we'll come back to that. We need to remember, use distributive property as many times as needed. What do you mean? In this case, 3x times both of these. That's one distributive property. In this case, which is a FOIL, x times x, x times 6, negative 6, that's one distributive property. But you also have negative 6 times this x and negative 6 times 6. So technically you have 2 distributive properties. So what that means is use distributive property as many times as needed, not as many times as you make up. The problem determines how many times is needed. Combine like terms and write in standard form. Standard form is simply biggest exponent to the left down going to the smallest, what's called descending order. Enough of that. Let's actually work some examples. The rest of the video I'll be working examples. Alright, so we got this first one. Remember, you might want to try to work this out. Write it down yourself and work it out. Pause and see what I do as I work the problem out. Alright, so here I go. What this means is x times everything here, negative 2 times everything here. Now, when I first teach this, I try to show people an easy way to look at it. You can take the x and multiply it by this whole parenthesis. 1 plus 3x minus x squared. You can take that negative 2 and multiply it by that whole same parenthesis. 1 plus 3x minus x squared. And let's do that. X times 1 is x. X times 3x is 3x squared. X times negative x squared is minus x to the third power, using the old exponent properties here. Negative 2 times 1 is negative 2. Negative 2 times 3x is negative 6x. Negative 2 times negative x is 2x squared. So what do you do now? Now you take both of these and add them together, combining like terms, starting with the biggest exponent down to the smallest. The biggest exponent I have in this whole sentence here is negative x cubed, right? So negative x cubed is first, but I don't have anything else. Now I have 3x squared and 2x squared, which make 5x squared. See, now I'm no longer multiplying. I'm adding or subtracting based on the signs. Now I have x to the first power. That's 1x minus 6x is negative 5x. And the last thing I have is a minus 2. This is called standard form or descending order. 3, 2, 1, 0 are the exponents there. Now, of course, guys, all you have to do, if you're thinking about this saying, that's too difficult. Yeah, you just had to write x times all of those. You could have wrote that out. Negative 2 times all of that. You could have just wrote that out in one long mathematical sentence. I just split this first one up so you can see how to work it. Normally, it makes way more sense, guys, to work the smaller one first and the bigger one second, but it doesn't really matter the order. The smaller terms, there's 2 terms here, there's 3 terms here. Now look at number 2. I told you in the notes that whenever you have something written out, it makes sense to go ahead and to expand it out. So this means this. Right? So I'm going to just take the first 2 and go ahead and multiply those. If I just ignore this one and multiply the first 2, this is a FOIL. That means this times this, first, outer, inner, last. Or think about it as simply 2 distributive properties. Alright? So x times x is x squared. X times y is xy. 2 different variables, write them in alphabetical order. Y times x is xy, not yx, because you want to write them in alphabetical order. If you don't write them in alphabetical order, you may not realize that they are like terms. They need to be in alphabetical order. And then y times y is y squared. Okay? Now look, these 2 middle terms become x squared plus 2xy plus y squared. Where did the 2 come from? There's a 1 right here. There's a 1 right here. 1 plus 1 is 2. How do I know I can add those 2? Because they have the same variables. Alright? Now, that's not my answer because I still have to multiply by this x plus y. Okay? So, me personally, I like to do the first 2 when it's 2 times all those, but since it's written like this, I'll just keep it going, not to confuse anyone. X squared times x is x cubed. X squared times y is plus x squared y. 2xy times x is 2x squared y. 2xy times y is 2xy squared. Now, y squared times x is plus xy squared, and y squared times y is plus y cubed. So, if you didn't understand that, you need to pause and go right back and see where each one of those came from. I took this times both of those, this times both of those, and this times both of those. Alright, simplifying. X cubed. Do I have any more x squared y's? Yes, I do, right here. What's 1x squared y plus 2x squared y? That's right, it's 3x squared y. And so do I have any more 2xy squared? Sure. 2xy squared plus 1xy squared is 3xy squared. And then I don't have any other y cubed, so it's just simply y cubed. And there's no other like terms left here. Alright? Go back and review that. Rewind that if you didn't get that. Now, if I made a mistake, act like I never did it. Alright, this last one here is asking you to take AB, that's one thing since it's not separated by a plus or minus, times each one of these here. Alright? Keeping careful watch over your exponents and stuff. So when I multiply AB times A cubed, I get A to the fourth B. When I multiply AB times 3AB squared, that's plus 3A squared B cubed. When I multiply AB times B cubed, I get minus, that's actually negative B cubed, that's minus AB to the fourth. Now, then you look and say, is there any other like terms? Can I add or subtract anything here? I don't have an A to the fourth, A squared. Even though I have A's and B's, they got to have the same exponents in order to add or subtract. So therefore, that is my answer. You'll get problems that are similar to this. They may not exactly be all the same, but based on these principles that I've shown you, you ought to be able to figure out any other problem that we have in this section. All right, ladies and specimen, be gone.